There's a special kind of quadratic equation that we refer to as a perfect square, and it comes when we have two factors that are identical. For instance, x plus 1 times x plus 1. So let's go ahead and multiply this out, see what we get. We've got x squared plus 1x plus 1x plus 1, ending up with x squared plus 2x plus 1. Let's try another one. Let's go x plus 3 times x plus 3. We're going to end up with x squared plus 3x plus 3x again plus 9. And we end up with x squared plus 6x plus 9. Now notice, as we multiply these factors out, we always end up with, for instance, x times 1 and x times 1 again. So this number always ends up being twice whatever this one is. And then at some point we have to multiply this number times itself, so this number ends up being this one squared. So let's look at this one over here. We had to multiply x times 3 and then 3 times x, so this number ended up being double that, or 6. And then we had to multiply 3 times 3, so this number ended up being 9. So these are properties of this special kind of quadratic equation called the perfect square. And you can kind of use it to go back and forth between the two. For instance, if I look at this number, which is double this one, so if I take half of it and square it, I end up getting this number. Same thing over here. Half of 2 is 1. 1 squared is equal to 1. So this is a property we're going to use to either find factors if we know the quadratic, or it's going to be used in a procedure to find the roots of any quadratic equation called the quadratic formula.